Hello! Today we'll solve another example where we'll apply all the rules of operations with rational numbers. In our example, it will be multiplication and division of rational numbers. Let's write down the example. 3.24 times 8.1 and multiply by the modulus of the expression 0.14 chat 0.64 and divide by the product of the following numbers 0.9, the modulus of the number minus 3.2 and the modulus of the number minus 0.75. Let's find the value of this expression. In order to solve this example, we first need to find the value of the expression that is contained under the modulus sign. To do this, we subtract the number 4 from 3.2 tenths. Now we know that the result is 0.8 tenths with a minus sign. So we multiply that by 8.1 tenths. And multiply it by the value of 0.14 hundredths minus 0.64 hundredths. This value will be minus 0.5 tenths. In the denominator, we can immediately find the absolute value for the number minus 3 whole 2 tenths and minus 0 whole 75 hundredths. The result is 0.9 tenths. Multiply by 3 whole 2 tenths and multiply by 0.75 hundredths. The numbers in the numerator are written under the modulus sign. Therefore, the modulus of a number minus 0.8 tenths is 0.8 tenths times 8.1 tenth times 0.5 tenths. And this product must be divided by the product of the numbers 0.9 tenths. 3.2 tenths and 0.75 hundredths. We calculate the numerator, and if we multiply these decimals, we get 3.24 hundredths in the numerator. And in the denominator, we get the next number is 2.16 hundredths. We divide 3.24 hundredths by 2.16 hundredths. We get the number 1.5 tenths. And that would be the answer to our example, but I want to show you another way of calculating the value of this expression. Not by multiplying numbers, but by working with natural numbers. What do we need to do this? Let's write down 0.8 times 1 tenth times 8.1 tenth times 0.5 tenths. Divide by 0.9 tenths, multiply by 3.2 tenths, and multiply by 0.75 hundredths. In order to find the value of this expression, we can move the decimal point a few decimal places to the right. And then we have a natural number, and natural numbers are much easier to work with. Let's multiply 0.8 decimals times 10. If I multiply 0.8 times 10, I get the number 8. I'll multiply 8.110 by 10. And I'll rewrite the number 0.5. But if I multiplied the numerator by 10 and then by 10 again, then I have to multiply the numbers in the denominator by 100. But I see that I have the number 0.9 tenths in the denominator, and I will multiply that number by 10. And I'm going to multiply 3.2, and I'm going to multiply that by 10. Now notice, I have 2 tens in the numerator and 2 tens in the denominator, and I will rewrite the number 0.75 hundredths. What is the result? 0.8 tenths times 10 is 8. 8.1 through 10 times 10 is 81. And the number 0.5 I'm rewriting. In the denominator, 0.9 times 10 is 9. And 3.2 times 10 is 32. And the number 0.75 I'm rewriting. As a result, in the numerator and in the denominator, I can divide 8 and 32 by the number of 8 in the numerator is 1, in the denominator is 4. I can also divide 9 and 81 by 9. 9 times 9, 181 times 9 is 9. And then I have the following product. 9 times the number 0.5, and in the denominator 4 times 0.75. In this case, we can once again multiply the numerator and the denominator by 10 or 100 or 1,000. But I see that in the denominator I need to move the decimal point 2 places to the right. And then I multiply the denominator by 100. But then I have to multiply the numerator by 109, multiply by 0.5, and multiply by 100. So I end up with 9 times 9. 0.5 times 100 is 100. 50 and 4 we rewrite, and 0.75 times 100 is 75. Let's divide 50 and 75 by 25. 50 times 25 is 2, and 75 times 25 is 3. We can further divide the number 9 and the number 3. 9 times 2. And in the denominator, 4 times 3, which is 4 and 2, I can divide by 2. That's 1 and 2. And 9 and 3, I can divide by 3. That's 1 and 3, which is 3 2s, and 3 2s, 1.5. There are different ways you can solve these kinds of solving these examples. In the next lesson, we will solve one more example with rational numbers. And today, our lesson has come to an end. Goodbye, see you again.